Scaling matrix. Scaling matrices are fundamental tools in maths used to resize objects in a 2D space. Understanding how scaling matrices work is essential for manipulating and transforming objects to suit specific requirements. In this short video, I will explore the concept of scaling matrices, their properties, and how they are applied to perform scaling operations in 2D. So, what is a scaling matrix? So, a scaling matrix is a square matrix that represents a scaling transformation in 2D space. It describes the resizing of points along the x and y axis by multiplying their coordinates by scaling factors. The general form of a 2D scaling matrix is given by this. So here as x, this is a scaling factor along the x axis. Sy is the scaling factor along the y-axis. So, properties of scaling matrices. Number one, scaling matrices are linear transformations. Number two, they preserve the shape of objects but change their size. Number three, or property number three, scaling by a factor greater than 1 enlarges the object, while scaling by a factor less than 1 shrinks it. By a factor less than 1 shrinks it. Property number 4, scaling by a factor of 1, it leaves the object unchanged. These are the 4 properties of scaling matrices. So how do we apply scaling matrices? How do we apply them? Let me see if I can write here. So to apply a scaling matrix to a point xy, into D, we use matrix multiplication as follows. X prime y prime equals to Sx 0, 0 Sy x y. So here you have the coordinate, which are the coordinates of the scaled point. X, y. These are original coordinates. Sx and Sy are the scaling factors along the x and y axis respectively. So let us look into this example. Stretch the triangle with vertices 2, 0, 4, 0 and 3, 2 by a factor 2 in height and a factor a half in width. The vertex matrix is A, so we take all the x coordinates, so you're going to have 2, 4, 3, 0, 0, 2. That's your vertex matrix. And our scaling matrix is given by a half 0, 0, 2. The new coordinates of the stretched shape is given by the product of scaled matrix and vertex matrix. So we take the product. So remember how to check the compatibility. So this is a 2 by 2 matrix. This is a 2 by 3. Okay. So this should give us a result of 2 by 3. So you get this. So now let us confirm using MATLAB. But first define a vertex matrix, which is this. And you scaled. For scaled, which is this. But take note here, you know that your vertex matrix A is 2, 4, 3, the first row, 2, 4, 3, but now you have 2 here. So for closed forms, repeat first coordinate at the end. This one we have 2 here. So for the second row, 0, 0, 2, and 0. So now our new coordinate of the stretched shape, it is going to be defined as this. And if we punch or if we enter, we get our new coordinates of the stretched shape, which is 1, 2, 1.5, 0, 0, 4. Confirms our calculated answer. So now let us look at the visualization for scaled matrix. So we have line 1, 2, 3, 4, 5. Okay, so now the first line, it creates a plot of points using the x coordinate from the first row of matrix, this one, and the y coordinate from the second row of matrix. And the points are plotted in green color. This one we have G here. The hold on syntax in line 2. So this command tells MATLAB to retain the current plot when subsequent plots are made. It allows multiple plots to be displayed on the same figure without overwriting the existing plot. What about line 3? This line creates a second plot of the points using the x coordinates from the first row of matrix I knew, and the y coordinates from the second row of matrix I knew. The points are plotted with dashed lines. What about line 4, hold off? This command turns off the hold feature, so subsequent plot will replace the existing plot rather than being added to it. It ensures that further plots will start afresh without retaining the current plot. Line 5. So you can say this is line 6. This line 5. This line 5, creates a legend for the plot. It specifies the labels for the different sets of points plotted. A represent the points from matrix A, and A I knew represent the points from matrix A knew. Line 6, it provides a descriptive title for the plot indicating the type of transformation being visualized.